Alright, let's finish up this worksheet here. Remote control buggy, so you got to put the scale on here. 1, 2, so 2, 4, 6, 8, 10, 12 seconds. 2, 4, 6, 8, 10, 12 meters. Alright, so it's at 0. 2 seconds, it's at 6. 4 seconds, it's at 12. 6 seconds, it's also at 12. Then it's at 8, 4, and 0. So something like that is fine. What do you think is happening from 4 to 6 seconds? So this thing's moving forward pretty quickly, right? So it's moving forward pretty quickly. And it stops, and it's there for a time interval. And then it moves backwards a little bit slower, right? That's called a motion map. It shows it moving forward, stopping, and then moving backwards slower, gets back to where it started. So this would be the scale here. This is 0 meters. So from 4 to 6, I'd say it's either standing still or turning around. How do I know? It stays at the same position of 12 meters from 4 to 6 seconds. Alright? You can see it's got the same position from 4 to 6. What do you think is happening from time interval 6 to 12? How do you know? Well, 6 to 12, that's when it's coming back to the starting point. Returning to the starting point. How do I know? The position goes from positive 12 meters to 0 meters. Right? It's at positive 12 at 6 seconds, ends up at 0 meters at 12 seconds. Determine buggy's average speed from 0 to 12 seconds. So average speed is the total distance over time, right? So the total distance is 12 meters forward, right? And 12 meters backwards. So the distance is 24 meters total. So it's 24 meters in 2 seconds. That's 2.0 meters per second. All right. Average velocity is, we talked about this in class, is change in position over time. Change in position is called displacement. All right, and if I made the same drawing, right, it's positive 12 meters, which is so displacement factors in direction. Positive 12 forward, negative 12 backwards. So the net displacement is 0 meters overall. So it's 0 meters in 12 seconds, or 0 meters per second, the average velocity. Cool. Forward 12, backwards 12. Net displacement is 0. Alright. We got another one here. Answer following question. So we're going to make the graphs here. Scale's already on here, so that's nice. So 0, 0. 1 is at 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, just to help me keep track of everything. So 2 is at 4. 3 is at 4, so then it moved from 2 to 3. 4 is at 7. 5, 6, 7. 5 is at 10. 6 is at 10, didn't move for that second. 7's at 10, didn't move for that second. Then 8's at 5, so now it's going backwards real fast. 9's at 0. So it's going forward, stops, goes forward faster, and stops. Hey, that's just like we did in class there. Then they go all the way back to the beginning real fast. Alright, so velocity versus time graph here. What I'm going to do is figure out the slope of the line over each of these line segments and then translate that over to here. So this is plus 4 over 2. So it's plus 4, rise 4 meters, right? And then the run is plus 2 seconds. So it's 4 over 2. That's plus 2 meters per second. This is 0 meters per second. Up here we're going plus 3 meters in 1 second. Right, over here, 0 meters per second. Then we go down 5 meters in 1 second. So it's negative 5 meters each second. I have to translate that over to this graph. So this is 0. This is positive 1, positive 2, positive 3, positive 4, positive 5. This is negative 1, negative 2, negative 3, negative 4, negative 5. Alright, so I'm just going to draw this axis in a little brighter here so I can actually see what's going on with the 0. Alright, so for the first 2 seconds, the velocity is positive 2 meters per second. So that's velocity there. I'm going to draw it nice and dark here. Then we drop down to 0 meters per second for that next second. Alright, and then for these next 2, we go up to positive 3 meters per second. Alright, positive 3 meters per second from 3 to 5 seconds. And then from 5 to 7, the slope of the line is 0, so we have no velocity. And then from 7 to 9, we go negative 5 meters per second, so I gotta go negative. And we don't know what happens after that. Determine the displacement from 3 to 5 seconds using graph B. Alright. So, here's graph B. Turns out the displacement, or the distance, right? So, you might remember average velocity V equals d over t, right? So, d is going to be velocity times time. So, it's going 3 meters per second for 2 seconds. Alright, so 3 times 2. Now, it says using graph B, so that's 3 meters per second for 2 seconds. Turns out that, so we can go ahead and figure that out. Now, since it's displacement, we will use the symbol delta x. D is distance. Delta x is displacement. Alright? And sometimes we use delta x, sometimes we use. So delta x is going to be 3 meters per second. Positive, we include it because displacement includes direction. Alright, and then from 3 to 5 seconds, that's a time of 2 seconds. So it should be, seconds cancel, you get positive 6 meters. Now, note that it's 1, 2, 3, 4, 5, 6 boxes here, or the area under the curve. Alright, so the area under the curve is the area between the line and the horizontal axis. An area under a V versus T line is the displacement. So we learned that the slope of a line means something, but also the area under the line can mean something also. So look, to find the area of this rectangle, you do base times height. The base, right, is 2 seconds. The height is 3 meters per second. So that's basically just the calculation we did there. Then 7 to 9, okay, that'd be from here to here. That'd be this area. Alright, and look, it's 1, 2, 3, 4, 5, 6, 10. So delta x is, I'm going to do the area. Alright, equals base times height. That's b times h. It's a terrible b. Or velocity times time. right, like we did over here. Whatever you want to say. So it's, the base here is 2 seconds. The height of it is -5 meters per second. So you got to put in the direction, right? You got to put in the direction -5. So the displacement is -10 meters, right? And you can see, read it off this graph too. It went down 10 meters in those 2 seconds from 7 to 9. Oops, none of that was showing up on the video. So delta x equals area under, base times height, or velocity times time. 2 seconds times -5, that's the base is 2 seconds, the height is -5, so distance -10. Or I could have just done velocity times time. Velocity is -5 meters per second times 2 seconds, so that would be like doing the height times the base. Height times base is what velocity times time would give you. Alright, that's it for the rest of this worksheet. I'm going to scan this, get this posted, and move on.